Now we get to start a whole new section of statistics, which is focused on how do we actually get data. We've learned what to do with data once we have it, but how do you get it? There are three basic ways. We can do surveys, we can do experiments, or we can do simulations, and that will generate data for us. And what we are going to try and do is figure out how do we have good designs of surveys, experiments, and simulations. And so this first part is the fundamentals of good design. And we're going to talk about lurking variables and confounding variables. There's going to be, I think, a couple of videos on these fundamentals. So let's jump in and see what we mean by lurking and confounding variables. So here's a wonderful definition of a lurking variable. A variable that has not been, that's important, identified, or included in the study, and yet may influence the relationship of the variables being studied, and therefore the conclusions that can be drawn. So, like I said, key is it hasn't been identified. Let's look at an example. Studies have shown that men who complain of chest pain are more likely to get detailed testing and aggressive treatment, such as bypass surgery, than are women with similar complaints. The question is the association between gender and treatment due to discrimination? This, of course, is a very important question, especially as it comes to medical stuff. And studies have shown, right, it seems pretty clear, actually, that there's a difference. But we need to ask ourselves one very important question. Are there any lurking variables? And as it turns out, there is. If there wasn't, I wouldn't use it as an example. And it turns out to be age. Age is a lurking variable in this case. Turns out, women who complain of chest pain are on average 10 to 15 years older than men who complain of chest pain. So there's actually a nice little diagram of lurking variable. Here are two variables, x and y, which we can say are gender of the patient making the complaint and the aggressiveness of the treatment. And there does seem to be an association, which we can use a dashed line to indicate. There's an association between those two, and studies have shown that. But there's a lurking variable, which we can denote with variable z, which turns out to be age. Is age a factor in the gender of the patient making the complaint? Yeah. Women are older, men are younger. Is age a factor in the aggressiveness of treatment? Yes. Aggressive treatment is more dangerous for older people. So doctors are a little bit more cautious. So although there's an association, there really isn't necessarily a cause and effect happening here. It's actually the age which is in play here. And as a matter of fact, when the gender versus treatment studies are reanalyzed with age factored in, the association between gender and treatment disappears. So the original question is, if you recall, is the association between gender and treatment due to discrimination? Well, the answer turns out to be no, it's not. It's due to age. And this gives you a very important insight into lurking variables. Once a lurking variable is identified, it can usually be factored out, which of course means it's no longer a lurking variable. Because if we go back to the definition, a lurking variable has not been identified. So once we identify it and factor it out, it's no longer a lurking variable. Now the difference between a lurking variable and a confounding variable is subtle. let's look at the definition of confounding. It's almost the same definition with just a little difference. A confounding variable is a variable that may or may not have been identified. Major difference. It might be identified or included in a study and yet may influence the relationship of the variables being studied and therefore the conclusions that can be drawn. So the second part of this is all the same as working variable. The only real difference is that maybe it has already been identified. Let's look at an example of confounding. The question, does living near high-tension power lines, the ones that have really huge voltage, does it increase the chance of leukemia in children? So are there any confounding variables? And of course the answer is yes, or I wouldn't use that as an example. And the confounding variable in this case is socioeconomic status. Turns out that property near high-tension power lines is usually not very expensive. And now let's look at our little X, Y, and Z diagram. Let's get the descriptions on. We have the exposure to electromagnetic fields. We have the chance for leukemia. There may be an association between the two. There may even be a cause and effect. Right? The solid lines are usually an actual cause and effect. There have been experiments in the lab with mice and rats and these sorts of things that very strong electromagnetic fields are a cause of leukemia in mice and rats in a laboratory environment. Of course, the levels of the electromagnetic field are much higher in the lab. These are much smaller. Some would say negligible. So the association may or even may not be there at the moment, but in the lab there is with non-humans. And then, do you think there's a influence or a factor between socioeconomic status and the chance of leukemia? Well, there's all kinds of factors. Once you start talking about socioeconomic status, there's a whole slew of factors that get thrown in, such as smoking and exercise and nutrition and work hazards. There's all kinds of associations between the incidence of these and socioeconomic status, which isn't to say that if you don't make a lot of money, you're going to smoke. No, not necessarily. But if you look at the whole population, there are generalizations that can be made. And do you think these might have a direct influence on leukemia? Well, yeah, there have been studies done, especially for smoking and certain work hazards. There are direct correlations there. And so this is another form of influencing the outcome of the study. So what's the difference between a confounding variable and a lurking variable? Well, for this, can we factor it out? The answer is no, not really. Or at least it's going to be very difficult to really factor it out. What we need is, people of a variety of socioeconomic statuses to move near high power tension lines, and then we can study them. Well, asking people to do things that they wouldn't want to do, forcing them in some way or coercing them in some way, is actually unethical. We can't really experiment on humans quite like that. So we're kind of stuck in a way, which means confounding variables can be very difficult to impossible to factor out once identified. Which is why in the definition, there is this may or may not have been identified, because you might actually be able to identify it, but you still can't factor it out. So what we're left with is the best way of dealing with working confounding variables is randomization within the study. This is an attempt to try and, if we can't eliminate it, at least spread them out so that it's not systematically introducing bias to the study. But that still may not completely solve the issue. You know, like the leukemia question. We can't randomize into other socioeconomic statuses very easily. So there are times when it's limited. But all good design for surveys, experiments, and simulations should have some form of effective randomization.